So this is the lesson 4 for design analysis and algorithm. So we will be discuss about exhaustive search. So exhaustive search is including all the possibilities to solve a certain problem. So exhaustive search is either it can be brute force approach or combinatorial problems. So when we say combinatorial problems, it includes the mixture of brute force and other algorithms. So it suggests generating each and every element of the problem domain, selecting those of them that satisfy all the constraints. So from the definition itself, so that satisfies all the constraint and then finding the desired element. So ibig sabihin dito sa algorithm na to is we will include all the possible scenarios, all the possible solutions, and then we will find what is the most satisfying or what is the most desired element. So the first exhaustive search that includes the TSP. So exhaustive search is ginagamit siya mostly when we are finding the shortest path, and at the same time mostly sa mga graphical problems and sa mga uh, weighting problems. Okay? So the first problem is the TSP or the traveling salesman problem. So this problem asks to find the shortest tour through a given set of N cities that visit each city exactly once before returning to the city when it started. So it doesn't matter kung city siya. So for example, ako, ang lakad ko is, ang schedule ko for today is bahay, SM, palengke, ano pa, school, bahay, SM, palengke, school, at saka milk tea shop. So, dahil hectic ang schedule ko, kailangan kong humanap ng way which is the fastest way or what is the shortest distance para ma-accomplish ko lahat ng mga pupuntahan ko. So, this can be modeled as a weighted graph with vertices representing cities and edge ways specifying distances. So, dito, hahanapin natin which is the shortest distance para malaman natin kung saan destination pupunta yung salesman or saan destination pupunta yung isang tao. So that is traveling salesman problem. Okay, so this is an example of traveling salesman problem. So for example, si traveling salesman is mag-start siya from A. So i-include mo lahat ng mga possible scenarios or lahat ng mga possible distances. You have to plot first and then you have to add all the distance in between the locations, and then you will find which path is the shortest path or which distance is the smallest distance among the distances. So this is the sample graphic problem to find the shortest path using the travel salesman problem. So in this travel salesman problem using the exhaustive search, so you must determine all the possible paths, possible solutions in order to solve a problem. So in this TSP, so we have to include all the paths that is given. So in this TSP, so lahat magta-trial and error tayo. So let's start. So in this problem, so we have one salesman. Titignan niya kung ano yung pinaka malapit or pinakamalapit na distance depending kung saan siya manggagaling. So, for example, nag-start siya from A or nasa A na lugar siya or nasa place A siya. So, we have to include all the possible paths na pwede niyang ikutan para matapos yung kanyang work. So, since nasa place A siya, so we have to plot A and then B, C, D, E. And then next will be A, E, D, A, E, D, C, B. And then, so yan. So, ito yung mga possible na pwede niyang ikutan. So, kung nakita naman natin kung alin yung mga possible na pwede niyang ikutan, okay? So, what if, so, kailangan natin i-plot din yung mga distance na kailangan natin i-solve. So, from A to B, we have 10 meters. And then B to C, we have 5. C to D, we have 3. And then D to E, we have 2. And then A to E, we have 15. E to D, we have 2. D to C, we have 3. And then C to B, we have 5. So, 10 plus 5, 15, plus 3, 18, plus 2, 20. So, 20 in total distance ng first path. And then, 15 plus 2, 17, plus 3, 20. Diba? 15 plus 2, 17, plus 3, 20, plus 5 equals 25. So, ano ba yung mas maikling distance? 20 ba or 5? So, ito yung pinaka shortest distance na pwedeng ikutan ng ng salesman using the travel salesman problem. So, depende yan kung saan siya mag-start. For example, nag-start siya sa B. Okay? So, another salesman, nag-start siya dito sa B. So, lagyan natin yung mga possible na paths. So, start from B. Okay? We have C, D, E, and A. Okay? So, pwede rin B, A, E, D, and C. Okay, same procedure. So, from B to C, we have 5. C to D, we have 3. D to E, we have 2. And E to A, we have 15. Then B to A, we have 10. A to E, we have 15. E to D, we have 2. And then B to C, we have 3. So, 5 plus 3, 8 plus 2, 10. Okay, so equals to 25. Then 10 plus 15 equals 25 plus 2, 27 plus 3 equals 30. So we have to compare them, and then the shortest path will be the first one, the B, C, D, and A. So that is for the travel salesman problem. Next is the knapsack problem. So given items of known weights, weight 1 to nth weight and values value 1 to nth value, and the knapsack capacity W, find the most valuable set of items that fit in to the knapsack. Okay, so this is another representation for the knapsack problem. Okay, now this is the sample for the knapsack problem. So in the knapsack problem, so this is the problem wherein you will include all the possible solutions. Okay, thing with the travel salesman problem, and then you will know what matches. Okay, so ito yung problem for the knapsack problem. So, sa knapsack problem, so may isang magnanakaw. Okay, may isang magnanakaw na pumasok sa bahay ng mayaman. And then, yung bag niya carries, okay, bag carries only a total of 40 grams. Okay? So, maraming mga items dyan na naka-display. So, si item A for 5 grams, $30. And then, item B for 10 grams, $15. For item C, 15 grams, $20. Item D, 25 grams, $14. And then item E for 30 grams, $45. Okay? So, kailangan natin i-consider lahat. Okay? So, the bag has a limit to carry 40 grams. So, knowing that magnanakaw, siguro kung ako yung magnanakaw, lahat kukunin ko, di ba? Kaya lang, ang bag ko is, yung kaya niya lang dalhin is 40 grams. So, kailangan natin mag-plot. So, kung pagsasamahin natin si A, B, and C, okay, A, B, and C, which is A equals 5 grams, and then B equals 10 grams, and then C equals 15 grams. Okay? So, 5 plus 10, 15, plus 15 grams equals 30 grams. Okay? So, equivalent ng 5 grams is the $30. 10 grams will be the $15. And then 15 grams equals $20. So you will add them. 30 plus 15, 45 plus 20, $65 ang makukuha mo. 30 grams can be less than 40 grams, so pwede niya pang mabitbit. Pero kung idadagdag pa natin si item D, which is the 25 grams, 30 plus 25 equals 55. So, hindi na natin ma-include si D. Kasi hanggang 40 grams lang yung limit ng bag. So, we have to consider other items. So, for example, item C, D, and E. So, item C is 15 grams. D is 25 grams. And then E is 30 grams. So, 15 plus 25 is 40. So, 15 plus 25 is 40. And then, 40 plus 30 grams equals 70 grams. So, 70 grams is greater than 40. So, hindi na mabibitbit ng bag. So, ang mabibitbit ng bag is the item A, B, and C, which is equivalent to 30 grams and then equivalent to $65. So, pwede pa kayong mag-include ng other possibilities like, so, siguro, let's try item E, so 30 grams, and then item B, which is 10 grams. So, 30 grams and then 10 grams. So, $15 equivalent to $15 plus $45 is equivalent to, for 15 plus 45, then $60. Kaso, mas malaki pa din ang makukuha mo dito. So, this is the solution to the problem of the knapsack problem using the exhaustive search. Next, we have the DFS or the depth first search. So, depth first search is the most fundamental search algorithm used to explore nodes and edges of a graph. So, dahil meron tayong keyword na nodes, so automatically, the data structure that is suited for this algorithm is the linked list data structure. And then, it run times with the complexity of O of V plus E. Okay? So, this depth first search pertains to the visited nodes using the stack data structure. Okay, mas ma-explain si DFS when we are going to sort a certain nodes using the topological sorting. So this is an example of the DFS. So nakikita ninyo it represented by nodes and each node are connected with the other nodes. Okay, in this illustration, I will show you how to solve a graphical problem using the depth first search. So in this side, so this is the pseudocode for the depth first search. Okay, so I will explain it line by line. So function DFS, so we will activate the DFS or the depth first search algorithm at, so the variable for at is the representing the nodes or the data allocation or the memory address of each data. If visited at, then return, and then visited at equals true. So, paano nag-work yan? So, I'll start at node 0. So, if you will ask me, kahit anong node po ba pwede mag-start? Yes, pwede po. So, itatrack lang natin kung ilan yung mga visit na or itatrack lang natin kung papaano mag-visit ng mga nodes inside the graphical problem using the depth first search. So, I'll start at the node 0. So, hanggat hindi pa na-visit yan, magto-true yung function. So, 2, then 3, and then 4, and then 5. So, doon natapos na tayo dito sa 5. Kaso, ang goal sa depth first search, kailangan lahat ng nodes is ma-visit. So, paano tayo magpo-proceed? So, we will proceed that by backtracking. So, I will backtrack from 5 to 4. And then, from 4, pwede ako mag-visit sa 6. And then, 7. So, makikita nyo, dito sa path na to is 3. Kaso, na-visit na si 3. So, magba-backtrack tayo ulit. So, from 7, I will backtrack to 6. And then, 8. So, nakita nyo, lahat ng nodes is na-visit. So, that is how depth first search works. So, if neighbors, for example, this node has a neighbor, equals graph at for next in neighbors and then depth first search next. Okay, so ito yung function for backtracking. Next, we have the breadth first search. So, this BFS or the breadth first search algorithm, okay, is particularly useful in finding the shortest path of unweighted graphs. So, specifically, si breadth first search applicable siya kay traveling salesman problem kasi they are both finding the shortest path possible. So, a BFS at some arbitrary mode. So, BFS is just the same as the DFS kasi si BFS, gumagamit siya ng queuing wherein the BFS list all the nodes that are visited. And then, check niya muna yung nodes before visiting the next neighbors pertaining to that certain node. So this is how the breadth first search works. So breadth first search is like the DFS or the depth first search. Kaso, ang pinagkaiba nila is breadth first search is accompanied with a queue data structure. So beside on the graphing problem or the graph problem is the pseudocode for the BFS. So previews equals null, which is it includes the size of the n that determines the size of the n or size of the node. And then while not queue is empty or the queue it first or yung lalagyanan ng queue is empty, and then node equals magdi-dequeue siya. And then neighbors, so kailangan niyang kailangan niyang mag-input or kailangan niyang i-visit yung mga nodes para mailagay doon sa queue. So, let's start. So, I will start at node 0. Okay, so since I visited node 0, I will put it on the queue. And then 1, and then 2, and then 3. So, since si 0, wala na siyang pwedeng ma-visit and na-stuck na siya kay 3. Okay? So, titignan muna natin, i-check muna natin. So, at node 1, may pwede ba tayong ma-visit? So, kung wala, let's skip. Sa 2, meron ba tayong pwedeng ma-visit? Okay? So, sa 2, pwedeng ma-visit si 3, kaso si 3 na-visit na natin. So, sa 3, okay, pwede tayong maglagay ng another node, which is the 4. Kasi, ito yung ma-visit starting from the node 3. And then 5, and then 6. So, dahil na-visit na lahat dito sa 3, so mag-check tayo ulit. So, sa 4, meron ba tayong pwedeng ma-visit? So, wala. 5, meron bang pwedeng ma-visit? Wala din. And then 6, pwede bang ma-visit? So, since visited na tong tatlong to, we go back to 3. And then sa 3, okay, may ma-visit pang nodes, which is 7, and then 8, and then 9, and then 10. So, lahat ng mga nodes is na-visit. So, for the queuing naman, pseudocode for the queuing. So, for next neighbors, if not visited, next, and then queue and queue the next. So, nakita nyo naman na ini-enqueue natin yung mga na-visit na. And then visited next equals true, and then prev next equals node. So, that's it. So, that's for the breadth first search.